All right, so now we're going to try a more powerful poisoning method, and we're going to use a different Python library, SecML, which is used to do security evaluation of machine learning, and it includes algorithms to efficiently poison them. So I install SecML and import SecML here, and that takes a couple of minutes, but that's already done. And now I'm going to prepare a data set. So this is going to be an artificial data set with 3 colors of points in a plane. There it is, importing random blobs and making random blobs as we've done them before. Okay, so now we have these 3 colors of blobs with X1 and X2 axes, and the task is, of course, going to be to sort these dots into their categories. And we're going to do it with support vector machines. So as you said before, the best vector is the one that makes the largest margin here, although in this case, you're going to have to use soft margins because the data overlaps. You cannot draw any line that will perfectly separate them. So we create and train the model here. And we're going to get there. So the accuracy on the test set is 98.8% now, and we can visualize the results. All right. Okay. And so you see it has chosen reasonable looking borders to separate the colors, and there are some errors, which is why we're 98.8% accurate. Now, an evasion attack is where you exploit the fact that we've been talking about a lot, that machine learning models do not work the way we do. So if you look at this thing and you recognize it as a panda, you recognize it by noticing the shape of the eyes and the shape of the ears and so on. So you process it into these edges. If you add a little bit of noise to it, like this, it looks just the same to a human, but to a machine learning model, it interpreted this as a gibbon with 99% confidence. And this points out the flaw of machine learning. Machine learning does not see the way we do. It doesn't first find shapes and edges and then interpret them. It just does a mathematical relationship between the pixels. So it will be using some strange combination of the color of these pixels to decide if it's a panda, such that this much noise completely confuses the model. And we're going to see examples of this. And this is what you can do with an evasion attack. An evasion attack carefully modifies data to create an image that will confuse the model. And it does it by understanding the model and looking at the parameters to figure out which pixels are really important and how much to change them to confuse the model. That's what's included in this SecML library. It has these attacks. So this is going to determine which point to move, or I think we chose a point. It's going to choose how much to move that point to optimally confuse the model. And there's some parameters here that determine how much it's allowed to move things. And it should give there. So it finds that if you move this red dot up there, that will have a large effect on the model. That dot is likely to be misinterpreted. So we're going to run the test and see how much how much we can confuse the model with various levels of perturbation. That's not listening to me. All right. Yeah, there we go. We should get this chart. And so the previous one was poisoning the data so the model learned wrong. This is an evasion attack where I take a fully trained model and I modify a input image so it's incorrectly classified. And I think I'll just go to the picture here. It's taking too long to run. So the point is, when you move it, when you don't move it, the model's almost 100% correct. When you move it, the further you move it, the more the accuracy falls down to random. And so you can now qualify how sensitive your model is to this attack. And there we are. And there's getting weird problems with my mouse. My machine seems to be bogging down, so I can't scroll very well. Anyway, maybe the keyboard? Okay. So that's what you have. And then there's going to be a few flags to find here. And you can see how much it would be to model, move various clusters here and there. You can see this synthetic situation. You can see how much you'd have to move things to confuse the model. And that's a start. So the next one is more easy to understand, though. So let me stop this recording and move to the next one. In this response, there we go. Stop. All right.